All right, so today we are going to start chapter 2, descriptive statistics. So 2.1, classification of data. This is your first thing that you're writing down in your spiral. And we're going to be talking about, population and collecting data from certain groups of population. So that question that I want y'all to have that's going to end up being your project, you need to be thinking about this constantly throughout this chapter. What you're measuring, is it qualitative, is it quantitative? And then figure out what type of graphs and data that you're going to use to represent that information you collect. So to figure out what those things are, this says there are two main types of data, qualitative and quantitative. So I want you to go ahead and pause and read this section here. Okay, so this is qualitative data is data. I don't know why it's R. I hate this data versus data. It's going to drive me crazy. I don't know how to say this, but that's what's happening. So qualitative data is not given numerically. For example, favorite color. Quantitative data is numerical. So that's a little vague. So I actually went ahead and looked up other things, and I encourage y'all to do that too, if that something doesn't make sense. But here it says quantitative data is information about quantities. So it's information that can be measured and written down. So things that you for sure can find out. Like I can find your height. I can find the height of a desk. I can find your shoe size or the length of your fingernails. Those are things that we can actually measure. Qualitative data, you cannot. It's like you're assigning a color to something. So if you're picking everybody's favorite color, you can do that. Here this says softness of your skin. So that's kind of a weird thing to do, right? Like how do you measure that? Do you go around and like touch people's hands? Like I don't know how you would measure that, but you would find some sort of way to measure that. That way you can put people in different categories. But again, that's a system you have to come up with. So if you have to do that, that's qualitative. If it's something where you can like get out a ruler or a scale and measure something, then that's quantitative. So if you need to add anything to your notes based on this, you can. There's also some examples here. Okay. So from here, the quantitative data, that's the stuff that you can count or that you can measure, you can break that into two other categories. So you can have discrete, and that's when you're counting things, right? Counted. So I would jot this down. So you could count the desks in the room, the amount of people that are wearing hats, people who have certain shoes on, like things that you can definitely count. So that would be in your number or natural set. The other type is continuous. So these are things that you measure. So like your height, your length. If I take half of your height or I try and use smaller units, like I can tell your height in meters versus centimeters. I can go from feet to inches. I can break them up to decimals. So like my height isn't exactly 5 feet. I'm 5'6". I can break it into smaller pieces. When you're counting something, you cannot break them into smaller pieces. Like if I have half of a desk, that desk is broken. I don't want to count it. Here, you can have everything in between. So like your weight, you could be 140.7, 132.2, something like that. It doesn't have to be whole numbers. So that's the difference between discrete and continuous. If you remember it from algebra when you did domain and range, discrete, you listed it. Continuous data, that was when you use those inequalities to represent it because it included all of the numbers between the whole numbers. Okay, you can finish reading this and include the examples in your notes. Okay. And I'm not sure if it helps you, but this is how I type my notes or how I would write them in my spiral. So if you want to take a moment and look at this, feel free. But basically, I just keep it short and simple. I go and take the key parts of it. I don't write everything down verbatim or word for word. And then I like looking at things in a list format. So I compared discrete and continuous. Okay. Moving on, you have your next topic, your population and sample. So go ahead and read this. Okay, so the key part is whatever you're collecting, you're taking it from somewhere, and that somewhere is the population. From all of the people, like if you're measuring something from a human standpoint, all the humans in the world would be your population. Your sample are the people that you actually measure from that population. And then a random sample is making sure that the people that you choose, it was random. Like you didn't just pick everybody with brown hair. You made sure that you were randomly collecting your data. A bias sample is one where you don't randomly select people. So if people are coming into a certain store and you want to know the type of people that shop there, but you're only picking people who... Okay, so an example of a bias sample, if you're trying to figure out all the people that eat at a restaurant throughout the day, and you want to figure out what kind of person eats at that restaurant. If you only go in the morning, you're going to get a biased sample because maybe the morning people have different characteristics from your afternoon or evening people. If you collected data randomly throughout the whole day, like you sampled every fifth person that walked in for the full 24 hours, then you would have a more random sample than if you just went in the morning. Go ahead and read this part. So the representative basically means that your sample that you pick accurately reflects the big population. And the only way that that happens is if it's random. You cannot have a biased sample. In your project, that's where a lot of people make mistakes. You can still get quite a few points, but in your math portion, you won't be able to get as many if you start off with a biased sample because you can't draw any conclusions on it because it's not representative. Okay, so to help have you randomize everything, they use picking numbers out of a hat. We can use a random number generator on your graphing calculator, which I will show you later. So example 1, go ahead and read this. Okay, so this literally just came from what we just talked about. If you're trying to ask random people at your school, you can assign people a number, randomly pick them. You can use the graphing calculator. So you should have listed something like that here. Example 2. Okay, so you should have that written down with what you think. And this is not random because if she's only asking people coming out of a specific store, she's leaving out all of the population because most people don't go to that store. So that's why this is not random. That would be a biased sample. Okay, so just a recap, you can compare your notes with how I took notes. I have a really clear idea of what these mean just because I did so much of it in college, so that's why I don't have any examples here, but you might need a little bit more, up to you. But with this, you should be able to finish everything from exercise 2A.